Good morning, everyone. Thanks for logging in and joining us on this first Wednesday of March, if you can believe it. Um, Today we have Pam Knox speaking with us, and she is the Senior Public Service Associate and the Director of the UGA Weather Network and Agricultural Climatologist. Pam is an agricultural climatologist for the University of Georgia Extension and the director of the UGA Weather Network. In the past, she has worked at the Wisconsin State Climatologist, the Georgia Assistant State Climatologist, and a meteorologist for the National Weather Service. In 2025, Pam was awarded the Extension Specialist of the Year by the Georgia Association of County Agricultural Agents. So, Pam, if you want to go ahead and kick us off, that would be great.
All right, and I'll let you let anybody in from the waiting room, so I don't have to pay attention to
Yes.
that. I will say that the date on my slides are wrong because I'm doing three talks this week and I just lost track of dates. So it's actually March 4 today, just in case you're wondering. And what I'm going to do is talk about um, hurricanes and tropical storms. I'm going to talk a little bit about what makes them. Some of you probably know some of this already. I'm just going to review it briefly so that people who don't know it as well can get a refresher and talk about climatology, when and where they form, some of the impacts that we see from them, and then talk a little bit about hurricane forecasting, both short-term predictions, when a hurricane is on the way to you, and the longer term predictions, which are really what we're talking about more right now. I'm going to briefly review the last couple of years. If I just reviewed last year, it'd be kind of boring because we didn't really have any tropical storms that hit Georgia. So I'm going to go back 2 years and then talk just briefly about the tropical forecast for 2026. So that's kind of where I'm going to go with this. And I do have occasional links on here since I think they're going to record this meeting. Um, you should be able to go back and get those later. And so let me start out by just talking about what hurricanes and tropical storms are. In every case, they're a very intense storm that has low pressure in the center of it. And the lower the pressure is, usually the stronger the storm is because low pressure is related to strong winds by physical properties that I have learned to calculate in meteorology classes over the time, and I'm not going to give you the math for that, but you can generally see when the pressure gets really low, then the center part of that clears out, and you have a central eye. It looks kind of like a donut um, that appears usually about the time it's transitioning from a tropical cyclone to a hurricane, which is related to the wind speed. In the Atlantic and the Caribbean, it's called a hurricane. It's basically from Spanish. Um, in other parts of the world, it's called a typhoon. In the Western Pacific, in the Indian Ocean, it's called a cyclone. But really, the generic name for all of them is tropical cyclones because there are also mid-latitude cyclones that provide cold and warm fronts to us and weather at different times of the year. I'm just going to talk about hurricanes in this talk because really we're talking about the same thing. And they around the low pressure, the wind blows counterclockwise. For those of you who don't use digital clocks or watches, that means at the top it's going to the left and at the bottom of the circulation it's going to the right. Um, so it's going counterclockwise, and the stronger the low is, the stronger the wind speeds are, and the strength of the hurricane damage occurs when you have really stronger winds. So where do they form? Well, they form anywhere that you have warm enough water. You got to have water that's at least 26.5 degrees centigrade or roughly 80 degrees Fahrenheit. The ocean water has to be pretty deep because as this development occurs, it pulls up water from underneath. And if it's really cold underneath, that kind of shuts off the development of the storm right away. So you have to have a relatively deep pool of warm water. In the heart of the hurricane season, most of the storms form off of the coast of Africa. And I'll show a picture in a minute of where the storms form at different times of the year. They move from east to west across the near equatorial parts, not right on the equator because it needs a force that we call the Coriolis force, which doesn't exist at the equator. So usually no hurricanes will be within 5 degrees latitude of the equator on either side of it. And it's just because the circulation can't develop. At high levels above the top of the circulation, winds are relatively light. If you have a strong jet stream up there, as we do sometimes, that kind of blows the top off of storms that are trying to develop, and so they don't really work. But you can see here the general pattern of the storms developing in the Atlantic Ocean. Sometimes they develop in the Gulf of Mexico. Sometimes they develop off of the west coast of Africa. Sometimes they develop some places in between, and you'll see that in some of the hurricane tracks that I show later. They also form in the Western Pacific. A lot of those can be very strong because the water there is really warm. They've had a lot of problems in the last year or two in the Philippines where they've been hit by several really strong storms over just a few week period and caused tremendous devastation. And we can also see hurricanes forming and hitting Australia. You see that there really are not any that hit in South Africa or in South America. That's because the Atlantic is too cold. It hardly ever gets temperatures that are warm enough to support hurricanes. I think there's been, if you look at the long-term record, there's been just one or two that have formed there, but that's not really an issue. You have to have that warm water or they're not going to form. So if we look at all the hurricane tracks for hurricanes that can affect the United States, you can see that development of a lot of the storms off the Cape Verde Islands, which is just off the west coast of Africa. But there's also a bunch of them that form in the Caribbean Sea or even in the Gulf of Mexico. And then there's also the ones that form in the Eastern Pacific Ocean where it's also warm. Those usually don't affect us except to bring some moisture into the southeast. And so that's not something that we really see here very often. Occasionally they can go into California or at least bring moisture into California and cause flooding there. But most of the time, when we're talking about the hurricane season for the United States, it's primarily in the southeastern part of the United States. You can see even up in Wisconsin, where I am from, they have had some remains of hurricanes that have gone through, but it's pretty rare. And mostly it's just a moisture thing that gets brought in. There you can see the recurvature. There's high pressure there. Around high pressure, the curvature is clockwise. And so that's really what's dominating the movement of the storms. And you can see in this diagram, there's a little area around New Orleans, Louisiana, that gets a lot of storms. And that kind of shows up in these path tracks as well. If you happen to be interested in looking at historical tracks for storms that come near your areas, there's a nice website at www.coast.noaa.gov/hurricanes that allows you to go in and query the complete database of hurricane tracks. And you can go in. This one I happen to do centered on 100 miles within somewhere along the path came within 100 miles of Savannah. This is just storms that at one point or another were major hurricanes. But there's other ways that you can go about doing that as well. And if you go into this database and hover over these lines, it will tell you the date of the storm, and you can click on that and go and get more information on individual storms. So even though lately most of the storms that have hit Georgia have been coming from the Gulf, and have come up through Georgia in that direction, historically there have been more that have come from off of the Atlantic Ocean. Some of the big ones occurred in the 1890s, like the Sea Island hurricane that caused tremendous amount of death. I think estimates of 3,000 or more, mostly from the storm surge in that case. And so there will be a time in the future, we don't know when that'll be, but there will be a time in the future when we may get another storm coming in off the Atlantic. And that is something to watch for. Lately, most of the ones that have been in the Atlantic have recurved and hit the Carolinas or the Outer Banks even of North Carolina before, and occasionally even into New England, like Hurricane Sandy, which went into New Jersey, I think. And so we haven't had any of those lately, but that does not mean they're not going to occur in the future. So that's something to keep in mind. The whole coast of Georgia is very vulnerable to these storms if they come on shore because it's very flat along the coast. There's a lot of marshes. And so if we had a really big storm surge like they did with Katrina of 25 feet, the amount of damage that would happen really almost all the way up to I-95 would just be really catastrophic. Hurricanes generally form in the time period when the ocean temperatures are the warmest. Occasionally, they can form as early as mid-May. More often, they form starting in late May. You see there's a little bump there in late May. But really, the hurricane season officially, at least so far, is considered to be June 1 through November 30. And you can see that's when the bulk of the hurricanes feel. The yellow lines there are the number of hurricanes that have ever occurred on a particular date, and the red line's the number of hurricanes plus tropical storms. So you can see the peak there is right around September 10th. That doesn't mean that you're going to get one then. It just means that over the whole time period of record, which goes back to the 1880s or even earlier in a few cases, that is when they have mostly occurred. And in 2024, we actually had some early and we had some late, but there was nothing going on around September 10. And so some years follow this classic curve, other years don't follow it at all. But that's the climatological difference. So if we look at storm formation by month, you can see it varies quite a bit from one month to the next. We start on the top left with June. Nearly all the early tropical storms and hurricanes form either in the Gulf or along the east coast of the United States. That's because that's where the ocean temperatures are the warmest, and we really have not had a lot of waves coming off of Africa yet. We're also usually getting a lot of dust that's coming off the Sahara early in the season, and that really suppresses the development of storms too. So the early part of the season is more close to the United States. And then by August, you can see there we're going into the more classic pattern where we have a lot of the storms develop near the Cape Verde Islands. It's really the strongest in September, and that starts to die out by October. And then November, we just have a few residual storms that are forming. It's important to note that the early storms in June and July, because they happen close to the coast, we may only have a couple days from the time they form to when they come on shore. And so you really have to be watching for this carefully because you may not necessarily have a lot of warning. It's not like you can watch the storm move 10 days across the ocean before it gets to you. That gives you more time to prepare. But you can see that if you have these storms that develop relatively early, they are in some ways more impactful to the southeast just because we're not really prepared for them and we don't have much lead time. Same thing is true towards the end of the season. Less likely to have long lead times to watch them grow and where they're going to go. And so you really have to keep watch the whole season and even in the edges around the season as well, because a storm could form in May and has before, or we've occasionally had storms form in December, or I think once even in January, just depending on if the conditions are right. If we look at a hurricane as a cross structure, you can see down there in the center is the low pressure, and then there's the eye of the storm where there's air. The air is in the eye is sinking, and since it's sinking, we don't really have a lot of clouds there, and that's what helps clear out the eye because of the sinking air. Around that, we've got inflow at the ground level. It's getting sucked into the low pressure because the atmosphere is always trying to equalize the pressure. Goes up into that eye wall around the eye itself, rises and cools and forms clouds, thunderstorms. And then as it gets up to the high levels of the atmosphere, it goes out and forms a complete circulation. So away from the hurricanes, we have sinking air. And if you're quite a ways away from where a hurricane is, you can actually be really warm and dry. Those are some of the areas that often are areas where droughts might form because they're not getting any of the rain from the hurricane. They're just getting that sinking air. So that is really what a hurricane looks like. So you've got rainfall near the center of the eye, not necessarily in the eye because you don't have any clouds there, but around the edges, you have that. If you look at it from a radar view, this is for Wilma, which is in 2005. You can see that there's an eye there right over Cozumel, relatively small. And so The red echoes like any other radar image. Usually red means more intense precipitation. So you can see the eye wall around the eye. It's kind of breaking up because it's so close to shore that they're getting interference from dry air that's coming in from the land. And then it's also going, I think, through an eye wall replacement. And then the farther out, there's these spiral rain bands that can also bring additional rain. Usually in a hurricane, you have these bands that come through, and you get a lot of rain, and then it might clear off for a while, and then you get another band that comes in, and then maybe eventually the eye wall. Those bands are where you can have tornadoes develop as well as flash floods. And the winds can be pretty strong in those as well. Hurricanes are classified mostly by the wind speed. They use something called the Saffir-Simpson scale, which is a five category scale, mostly based on the wind speed. Although obviously there's other impacts that we know from hurricanes as well, and I'll go through those in just a minute. But you can see that it goes up. The wind speed tells you something about the amount of damage to expect, but it's not a straight linear relationship. If you double the category, the wind speed, if you double the wind speed, the damage is four times as great because it's an aerial thing. It depends on the area. So areas, it's one side by another side. Um, and so the stronger the hurricane is, the much more intense and much more damage you're likely to see. Usually anything that's a category 3 and above, it's about wind speed of 105 miles an hour or so, is considered to be a major hurricane, and it goes up the scale quite a bit from that. It's based somewhat on damage, but mostly on wind. Now they're starting to incorporate other things like storm surge and rainfall, but um, it doesn't necessarily take a strong storm to do a lot of damage if you get a lot of rain from it. They can estimate it in real time because of the size of the storm. They look at the pictures on satellites and the forces and the winds that are going into it, and they can do a pretty good estimate of what that scale is over time. We look at the typical hurricane life cycle, and these are diagrams for one of the storms that comes off of Africa. So in the main part of the season, on the left diagram there, it usually starts off as a wave in the air pressure at the surface, and then that tightens up as it goes over the warm water, and eventually forms a circular pattern. And at that point, we call it a tropical depression. If there's a circular pattern and there's low pressure in the center of it, as it strengthens as it continues to go over the warmer water, you can start to see the development of an eye. Most often that happens right around the time it's a top end tropical storm or a low category hurricane. And sometimes the eyes are big, sometimes they're small. Um, the wind, if you have a really small eye, you're likely to have hurricane winds only really close to that eye. If it's a big eye, then the winds are going to be much more widely distributed over space and time. You can see usually the pattern is that the hurricane will recurve. It'll go up to the northwest, and then it will get caught in the circulation around high pressure, the Bermuda High in the central part of the Atlantic Ocean, and start curving so that it moves back to the northeast. Often at that point, it starts to ingest colder air, and it often turns into what we call an extratropical cyclone, so that it's not really all warm weather at the bottom anymore, but it's now looking more like a typical wintertime low pressure center that we have, and it can develop fronts and so on, and it moves off. If the high is moved a little bit to the west, we're more likely to get those make landfall. If the high is moved off to the east, then we're more likely to see what we call fish storms, or storms that never really hit land. And on the right-hand side is just a photo montage of Hurricane Isabel in 2003, taken once a day. And you can kind of see how that storm developed, how it looks and changes as it goes through the development. Usually it got an eye pretty early, and then it hit some colder water, and so it kind of weakened for a couple days and then redeveloped as it got back over warmer water. And you can see it developed really quite a big eye, and then started to shift off to the northwest. And for Isabel, it actually did make landfall along the Outer Banks. It was already becoming extratropical by that point. You can see the eye is kind of falling apart there. So it's starting to change its dynamic category as it goes through this life cycle. But that's typically what it is. You see an eye in a satellite picture, it's probably going to be at least a hurricane. Some of the hazards that occur in hurricanes and tropical cyclones in general, of course, the number one that we always talk about is the wind speed. Wind is driven by pressure gradient. So when you have a really strong pressure gradient, as you can see here, this is the pressure gradient as Hurricane Maria went over the Puerto Rico in 2017, how much the pressure dropped. And as the pressure drops, the wind picks up quite a bit so that you can have, in the most extreme cases, sustained winds of almost up to 200 miles an hour in the eye wall. Gusts can be even higher than that. Gusts are these instantaneous short-term winds that can occur, but usually hurricanes are measured by sustained winds, which is an average over like 1 minute or so. And you can also have sometimes tornadoes. And Ivan in 2004, I recall, I was here in Athens at that point, and Hurricane Ivan made landfall in Mississippi. And at about exactly the same time, we had a tornado go through Athens. That's a long ways away. So the impacts can happen a long ways away. So you always have to be concerned about tornadoes when you have a hurricane that's coming on shore. And I'll show some of that in just a minute as well. The eye is usually considered like halftime of the hurricane because often, the sky will clear up and the winds will die down and you'll have at least a few minutes, sometimes as much as half an hour or more, if the storm goes right over you, of calm conditions. People sometimes go out and they don't think about when the other side is going to hit them, and the wind comes from the other direction when the eye wall passes, and it can be just as strong as it was coming in. And so people need to be aware that if you're in the eye, it's not going to last, and they need to be very careful about going out, and they could maybe go take a quick peek, but they don't want to be out for any length of time because the other side of the eye wall is coming. It's important to keep in mind too that hurricane winds are a combination of the forward speed of the storm as a whole. And this particular diagram, the diagram, the storm is moving to the left. You can see there the storm speed 10 miles an hour. And then the circulation around the eye counterclockwise as it's drawn here. The strongest winds are where you have the wind of the hurricane moving in the same direction of the storm as a whole. So usually we say that's to the right of the storm direction. So that's usually where you expect to see the most damage, and the most likelihood of tornadoes as well. On the other side, the wind speed is going to be the speed of the wind in the hurricane minus the speed of the storm that's moving, because if you know anything about vectors from calculus, they're in opposite directions, so the net wind speed there is going to be lower. But it's still going to be strong, and so you want to make sure you don't minimize that. In Hurricane Michael in 2018, you can see this is the path. This is where the wind speeds were tropical storm and hurricane force. The strongest wind that was measured in Georgia was measured at Donaldsonville at one of the UGA weather stations. We reported 115 miles an hour. That was at 11 feet off the ground. And that was the highest wind speed that was reported in Georgia. Surprisingly, our station survived with just a few cables kind of flapping around in the wind, but it measured everything perfectly. And so that is the record that's showing in the National Hurricane Center's report on Michael as well. Michael was still a hurricane as it went into southwest Georgia, and it stayed a hurricane for a good part of the way. They had rainfall of up to 13 inches in Florida. We had more like 10 inches here in Georgia. You can see the map on the bottom left there shows the map of the wind gusts. And you can see wind gusts stretched for a long period, a long way into the state. The rainfall in the center of the three bottom pictures shows a lot of rain along the path and even a little bit to the left of the path. It just depends on what's interacting with. And then a picture on the right there of the eye as it hit um, Mexico Beach in Florida. And just it came on, it developed really quickly because the ocean water was very warm off the coast of Florida, and it just blew up in a day and a half from a category 1 to a category 4. That's really what we worry about because that intensification is something that's a little hard to predict, and that really determines what the wind speeds are going to be. So that is certainly an issue for wind. And I'm sure you saw the pictures of all the pecan trees that were knocked down and all the timber that was knocked down. Um, Also came on shore, unfortunately, right about the time a lot of people had defoliated their cotton. And so a lot of that cotton was just blown off the plants onto the ground, and you can't really harvest it then. So a lot of cotton losses. Peanuts had problems because a lot of the buildings where they take in the peanuts were destroyed. And so they didn't have anywhere to bring their peanuts, even if the peanuts themselves were still in the ground and they were still safe. So that is something that always have to keep in mind. Of course, a lot of times these hurricanes come right around harvest, and it's always hard to know how that timing is going to work. Another hurricane hazard that we often see is rainwater flooding. You could have flooding from the ocean, but you can also have rainwater floods. This is a diagram of what happened in Hurricane Harvey near Houston, Texas, and there the hurricane came on shore and it stopped. It was just kind of wiggling around the same area, and some places got over 60 inches of rain. One of our former students lived in Lake Charles, Louisiana, and he went out and helped do the storm surge or the storm survey afterwards, and was one of the people that discovered this rainfall of 60 inches. And if you have any topography like they did with Hurricane Helene, and you also have uplift from the topography, that can also cause really maximum amounts of rainfall. Um, in Georgia, the biggest rainfall we ever had was not from a hurricane, but from a tropical storm Alberto in 1994. See, it's right at the end of June into early July there on the map on the left-hand side. And it was one of these cases where the storm was only moving about 3 miles an hour. So it was dropping rain at a tremendous rate, tremendous flooding. The state record for the most rain in a day was from Americas from in this particular storm. They got a total of 28 inches. I think 21 of that fell in a single day. Um, so that was a lot, but Macon had tremendous problems. You can see the interstate picture there on the bottom right. You've probably driven over that um, a few times, perhaps, and it was a mess. Had a lot of problems with power outages and roads that were blocked off or destroyed in some cases by the flooding. And so, really, it can be a long ways inland. It doesn't have to be just in coastal areas that we're getting these impacts. There's a rule of thumb that some forecasters like to use. It's called the Kraft rule of thumb to estimate the maximum rainfall in a tropical cyclone. If you take the rainfall in inches is equal to 100 divided by the forward speed of the storm in knots, or you could use miles per hour. It's close enough. So for the case of Americas and tropical storm Alberto, it was 100 divided by 3 miles an hour. So the amount of rainfall they were expecting from that was about 33 inches, which is 100 divided by 3. For Michael, it was moving about 10 miles an hour, so 100 divided by 10 is about 10 inches of rain. So if you know how fast the storm is going to move, you can start to say something about the amount of rain that you're likely to get out of that storm. In general, storms that move fast have less rain damage and less flooding damage because they're not dropping a lot of rain at any one place. But they do cause more wind damage because then you get that whole vector effect of the forward wind speed plus the speed of the winds around the center of the hurricane. But slow moving, you're more likely to get rainwater flooding damage because they sit in one spot at rain for a long time period. Another hazard that we see from storm surge is, or from hurricanes, is storm surge. And this is a case where you've got this low pressure and you've got these strong winds that are causing water to move upward in the middle of the storm. It's partly because of the pressure. A lot more of it is because of the wind speed, because the wind speed is pushing against the water and it's causing the water to pile up ahead of the storm. And so you get these domes of high pressure, domes of water, excuse me, that move out ahead of the storm. And as they come towards the land, of course, you usually have shallow areas, and so the gets even taller because there's nowhere for it to sink down, and so it piles up. Um, a little bit of it's from pressure, but most of it is from the wind. And that water, just because water is so heavy, it causes tremendous damage. It just wipes out everything in its path. And some of the storms along the Gulf Coast, like Katrina and Ivan, you could see bathtub rings where the water was able to reach. And there is complete devastation where the water could hit. And then areas that were just outside of that had damage from the winds, but that might just have been some shingles off of the roof. So it causes tremendous trouble. That's why if you know the storm surge is going to be high, you really have to make sure people get out ahead of time. Katrina, the storm surge got up to 28 feet. I've been told that Jim Cantori, who's with the Weather Channel, picked a building that really wasn't very safe, and they lost a satellite truck because they got caught in the storm surge from that. Although the people themselves were in a safe building, so they didn't have any um, worries about their own safety. They just lost this equipment because of that. Storm surge in the southeast. We have quite a big continental shelf, so that if we would get a big storm surge coming on shore from a storm that's coming from the Atlantic side, we could get tremendous damage like that as well. The example that is probably the most common for the east coast of Georgia is the Sea Island hurricane. There were actually two hurricanes that hit the east coast in 1893. The Sea Island hurricane was the bigger damage, hit the coast near Savannah. The fatalities, depending on how you count them, 100 or 1,000 to 2,000 or more. Back in those days, they didn't keep very good track of some classes of people, and so chances are it was probably higher than that. Damage was $1,000,000 in 1893, which of course would be much higher now. The highest wind speeds that were measured was 120 miles an hour, and you can see there some of the pictures of just the devastation from the storm surge of that. Most of the deaths in the Sea Island hurricane were from storm surge. Because they were stuck in these low-lying areas. They couldn't get out because a lot of the roads are in low-lying areas as well, and you get trapped after a while. Or they didn't get warnings back in 1893. Of course, they didn't have nearly as many warnings as they used to. And so that is something that you on the coast are going to have to watch for in the future. Because sooner or later, one is going to hit, and you have to be prepared for that. Hopefully not anytime soon. So this is kind of how the storm surge works. You have the water that's getting piled up with the wind ahead of the storm, so it's coming on. Mostly the strongest storm surge is usually to the right of the storm because that's where the winds are the strongest. And they push this water ahead. And then on top of that, you also have waves, and the waves can be 10 feet on top of that. So that's adding to the amount of destruction that can occur in the storm surge. So a lot of problems. That's why having protective dunes is really important because it helps reduce the amount of force from the water a little bit, or in some cases can prevent it from getting into areas. But storm surge can cause tremendous problems. It can wipe out the roads along the escape routes. And so you got to make sure people are out early. And sometimes some of the places along the coast, it may take a couple days or more to get people out. And so you have to be prepared for that. And if the hurricane path isn't well predicted, they might have to get out of a place thinking that the hurricane will hit, and then the path will change and it will go somewhere else, and people will complain that why did you make us evacuate? Because it costs like $1,000,000 per mile to evacuate along the coast, and so there's a lot of costs involved with that. But the cost that you don't really talk about is the cost in human life, and that's very important, of course. I want to switch now and talk a little bit about forecasting. There's two kinds of forecasting when we talk about hurricanes. One is the forecasting of individual storms, and then the other is the seasonal forecasting. So I'm going to talk about the forecasting of individual storms first. They use just like any weather model, they do a lot of forecasting using computer models, and there's a whole bunch of different computer models that they use, maybe 80 to 100 or so different runs that they use, and they kind of look at if they're all bunching up in one place, we have more confidence that that's where the storm is likely to go. If they're spread out, we have less confidence. They're starting now to use some AI models as well. Those last year was really the first year that they did that. Relatively good because it can find things in the data that you might not be able to find on your own. And so the models were really bad at first. These are you forecast the track or where it's going to go, and you forecast the intensity, which is how strong it's going to be. And generally, tracks are forecast better than intensity. And so you can see over time, starting in 1990 to this graph goes to 2018, there has been a decrease in the error. So that means that you've got better forecasts than you used to because where the hurricane actually went is closer to where they're forecasting now than it was. I don't know why it went up in 2019. I'll have to look at the individual storms for that. But in general, there's been a big improvement, and that's why now they can start to do forecasts up to 120 hours ahead of time with some confidence because those forecasts now are almost as good as the forecasts of the just 24-hour storm were in 1990. That's how much the computers have improved over time. We look at the intensity errors. There are some improvements, but they're not improving as fast as the location. And so that is something it's really hard to do because it depends on the sea surface temperatures. It depends on what else is interacting. It depends on the winds aloft and how much that vertical circulation is allowed to develop. So what you're going to commonly see when you look at a hurricane forecast is this cone. The hurricane cone will show you the current location. You can see there in the yellow. It shows you where the storm is likely to be for up to 3 days in the solid, and then the dotted is an additional 2 days or so. I think now they're up to a 7-day cone. And so you can see where it's likely to go. People tend to focus on the middle of the cone. Not a good idea because it could happen that the cone only tells you where the center of the eye is for one thing. And it's not always right. The cone could be anywhere, or the hurricane could be anywhere inside that cone 66% of the time. So it's not even right perfectly. It just tells you most of the time it's the center of the storm is likely to be in that cone. And because the right side of the path is usually where the most impacts occur, I've drawn a yellow circle there just to keep in mind that you need to be watching that area in particular, but anywhere in the cone could get impacts, and even to the left of the cone could get impacts, especially rain. So that's something to keep in mind. And gives you an idea of where the storm is likely to be. They update these every 3 to 6 hours. And so you're going to see some changes over time in that cone. And they will talk about that in television reporting. Oh, the cone is shifted to the right or shifted to the left. And every time they make a shift, of course, you got to calibrate what your own thinking is for your location, especially if it's coming right towards you. If it's like this and it's far from the Georgia coast, then the most likely impacts you're going to see are maybe some big waves and storm surge along the coast, and possibly some tornadoes or some heavy rains if you have a rain band that comes through if it's a big storm. The cone generally gets bigger with time because there's more and more uncertainty as you get farther from the current time in the forecast, just like there is with the weather forecast. This is an example from Hurricane Helene of where the center of the cone was. All those blue lines are where the center of the cone was at different prediction periods, and then the solid black line is where it ended up actually going. It was inside the cone, but it was on the very far right edge. So people were really worried about the hurricane coming right over Atlanta. And it turned out that because of other interactions with the front in the area and so on, that storm actually moved a little bit further to the right than was expected. So you have to be prepared for that. Even if you don't think it's going to come over you, you have to be prepared for that possibility. I remember being in Athens and watching the winds change direction as the eye went over the storm. The storm went over Athens. Of course, we didn't get nearly as much damage as areas to the right of the storm did. And I'll talk about Helene again in a few minutes. So don't focus on just the center part of that cone, but focus on the whole cone and even areas, especially to the right of that path of the storm. Forecasting results, generally they are improving. The number this is for the seasonal forecast. This is not for individual storms, but for seasonal forecasts. So people are saying, "Oh, we'll get maybe 14 named storms this year," and so they don't say where they're going to go. They don't say how strong they're going to be. They don't necessarily say if they're going to be tropical storms or hurricanes, but they will get the number that are expected to occur. They've generally been pretty good. This is from Colorado State. That's kind of the number one group that does these seasonal forecasts. And you can see they have been improving, but they're certainly not perfect. Some of these storms are pretty short-lived. You might have some named storms that only last for a day or two before that they kind of fall apart. But there's still going to always be some uncertainty. This is just an example of the forecast for 2021. Just so the Colorado State actually issues three separate forecasts, one in early April, one in June, once they can get a better sense for what's happening with the season, and then another one later in the summer as they get to see more of what's happening with some of the early storms. And they keep track of the number of named storms, number of hurricanes, the number of major hurricanes, and then some other things like the accumulated cyclone energy. That will tell you something about how long the hurricanes have been around and how strong they've been overall for the whole season. So in 2021, they predicted 20 named storms. That was much more than average, because average is about 14 or so, with 9 hurricanes and 4 major hurricanes. When this original graph was done near the end of 2021, they had already had 19 named storms with 7 hurricanes and 4 majors, and they ended up with more than that. So this long-range forecasting was developed by Bill Gray in Colorado State. He is unfortunately no longer alive, but he has folks there that follow the same techniques to calculate this. They looked at the number of hurricanes depending on long-term things like whether or not we're in an El Nino or La Nina. They look at whether or not we're in a drought, where the low pressure, the high pressure in the Pacific and Atlantic Oceans are, because that will help to stir them around. And they also look at what the likelihood is of having really strong winds aloft, which is usually more likely to occur in an El Nino year than a La Nina year is. And I'm not going to spend a lot of time explaining El Nino and La Nina, but I'm happy to do that if we have time for questions at the end. I think probably most of you have heard those terms before. So they will do sometimes an early forecast in December. I have not seen one this year. I think it may be that they just decided December was just too far out to do forecasts. So I expect their first forecast to probably come in January. Here's just another example of 2022. Other things that have recently come into the forecast is the amount of dust that's coming off the Saharan desert. You know, the Saharan desert covers a lot of the northern part of African continent, and it blows from east to west. So it's blowing all this dust over the atmosphere that's above the ocean, and that dust actually absorbs sunlight and gets warm. And if you have really warm layer in the atmosphere, that can inhibit any development of tropical cyclones, because tropical cyclones need the warmth to be at the bottom. And if you have warmth higher up, then the storms just don't really grow vertically. And so the last few years, we've had some early storms that have just really been shut down because we've had so much dust in the atmosphere. Sometimes this dust can make it all the way to Florida. Not always. And usually it's much stronger at the early part of the season than it is by the time you get to the main season in August and September. So this is just an example of what you get, this really warm air that's above the surface, and it creates what we call an inversion. That inversion really keeps the storms from developing vertically. And so that's something that they're now bringing into their seasonal forecast. If they expect to get a lot of dust, that's probably going to cut down on the number of storms that they'll get. Sea surface temperatures is also really important, especially for intensification. If the sea surface temperatures are unusually warm, that is a source of energy for storms to develop. This is a diagram that shows Hurricane Katrina, which it came over Florida first. It wasn't very strong yet, came over the Gulf. And you can see that area of red there was where the sea surface temperature was just incredibly warm. And as that hurricane went over that incredibly warm water, it just blew up into a Category 5 storm. It had weakened somewhat by the time it got to shore in the United States, but if it moves over that, can cause very rapid intensification. That happened with Hurricane Michael. Um, really rapidly intensified because the sea surface was so strong just off the coast of Florida there. And then Hurricane Ian a few years ago, which hit the southwest coast of Florida, which also blew up to a Category 5 because sea surface temperatures are so much warmer than they used to be. So we think because sea surface is generally increasing in temperature, the number of intense storms is likely to go up, although we don't necessarily think that we're going to get more storms. Um, Also, when you have really warm temperatures like that, you get more evaporation. So that means the amount of rainfall from these storms is also likely to go up, especially if it's not moving very fast. So I want to spend just the last few minutes here talking about the last few seasons and to do the forecast. This is 2024, 2 years ago. And you can see we had two storms, or Tropical Storm Debbie and Hurricane Helene, that went over Georgia. And we did have impacts from a couple of the other storms, mostly extra rainfall, which was good because it kept us from getting any droughts. Um, all right, so Tropical Storm Debbie happened right around the early part of August, and it came on shore in Florida. And by the time it got to Georgia, you can see in the middle graph there, the red is where it was hurricane force, but by the time it got to Georgia, it was all tropical storm force winds. The rain, it was really the big question mark and the big issue in Georgia. And if you know anything about hurricane insurance, the insurance map where they paid out is on the right-hand side there. The green areas are areas that got hit by a combination of wind speed, sustained winds that were tropical storm force, plus they had 6 inches of rain over a 4-day period. And the brown counties are areas that were next to one of those, or contiguous counties. So those were areas where they got tropical storm payments. You can see down in Florida, they actually, because the winds were stronger, they got hurricane insurance payments from that. For Hurricane Helene, it was stronger. Also, one case it grew quite rapidly as it went over the Gulf of Mexico, which was really warm at the time, and it stayed a hurricane almost all the way up to Macon. You can see the rainfall in the center part there. There's a lot of rain over Atlanta, and then also a lot of problems over Augusta. Athens, it actually had relatively little. I think I had about 5 inches at my house in Athens. And then the rain was also really strong in western North Carolina. They remember they had tremendous flooding there. Of course, the mountains compound that because there's rising motion and there's limited drainage areas, so that made things much worse. In Helene, a diagram on the right there shows where the confirmed tornadoes were from the storm. They're all on the right-hand side of that path, as you'd expect. Some are closer, but some are quite far away. And so the rainfall in western North Carolina actually fell as two batches. One as what we call a predecessor rain event, or pre, which sometimes occurs ahead of a hurricane. So they were already really soaked from rain even before the hurricane came on shore. And then the hurricane brought a second dose of heavy rain, which is really compounding the problem because there's nowhere for it to go. The ground just can't take in that much rain. So if we look at fatalities in Helene, down along the west coast of Florida, there were actually a few folks that were injured or killed by storm surge. In Georgia, it was mostly due to wind, power outages, trees falling on houses. And then up in North Carolina, it was more of a rain event. So the impacts are different depending on where you are for each of the different hazards that we have in hurricane. The map in the center there just shows where the power outages were. Most of the power outages were really near or to the right of where the storm happened. Part of that was because it was wet. So the tree roots don't have a whole lot of integrity if the ground is wet, and so it's easier for the wind to pull them over. Um, the hurricane warnings and tropical storm warnings. Hurricane warnings were actually a little farther to the west of where the worst winds were, and I'll show you that in just a minute. So Helene caused the whole state to be in either a tropical storm warning or a hurricane warning. And then it stretched through most of South Carolina and Western North Carolina as well. For those of you who know anything about the hurricane insurance, The insurance payouts were the map on the left, which actually don't correspond to where the winds were the strongest because of the data set that they use. I have been talking to lawyers about this. Um, not quite sure how to deal with that. Some people got payouts where they didn't really have very strong winds, and other people, especially along the coast, didn't get payouts at all because they were not in the area that was designated as the hurricane area. On the right-hand side is a map that shows what the Weather Service said the peak wind gusts were from Helene. You can see that's shifted off to the right of where the hurricane insurance people said it was. Strongest winds that we had were down in Valdosta, which were just under 100 miles an hour at our site down there. So in 2025, of course, we didn't have any hurricanes in Georgia. The only thing that hit was Tropical Storm Chantal in the Carolinas. Dropped a lot of rain, but nearly not much else. See, everything else, the high was shifted to the east last year, and so everything followed that path around the high and stayed off the coast. And so we had a very uneventful 2025. The last time that happened was 2015, and it certainly can happen, but not very often. So I expect we're going to probably see at least one or two landfalling storms this year. All right, and the very last hurricane that hit um, anywhere in the past year in the Atlantic was Hurricane Melissa, which hit Jamaica. You might remember that in October. It started not all the way in the eastern Atlantic, but in the western Atlantic late in the season. The winds before landfall were just upgraded this past week to 190 miles an hour, which ties the record for the highest winds in an Atlantic storm. Cool picture there on the bottom left of what it looks like if you're in the eye from one of the hurricane hunters. They call it the stadium effect because you can see it's perfectly clear sky up above, but it's like being in a bowl. And then the path of the storm on the lower right there. So for the final couple slides, what do we expect in 2026? Well, there's really no official forecast yet because it's a little too early. The first is really expected in April 2026, but I did see, and I'll show this in just a minute, there was one published by one of the Atlanta television people. So the average number is 14 named storms, 7 hurricanes, and 3 major hurricanes. We're in the process of going from a weak La Nina through neutral conditions into an El Nino. So by later in the summer, that could reduce the number of hurricanes, mostly because the jet stream is stronger when we have an El Nino. And so the jet stream is going to blow the tops off of those storms before they really develop. So the number will probably be predicted to be below the long-term average. Sea surface temperatures are increasing, but that could mean that intensification could be faster. Whether or not the number of storms is unlikely. So this is the official forecast or the unofficial forecast from Jeremy Nelson at WJCL, which I just saw when I was putting these slides together a couple of days ago. And he's predicting the forecast number of named storms 9 to 13, which is a little bit less than the average. A number of hurricanes 4 to 6, a little less than average, and the major hurricanes 1 to 3. That I expect is going to be very consistent with what the more official folks do when we get into April and beyond. But I will say it only takes one. If that hurricane hits you, then you're going to get all those huge impacts. And so you have to prepare for everyone as though at least in the early periods, as though it could come to you until if it's going to Texas, you're probably safe. But otherwise, you have to be prepared. So that's all I've got. I think I have a couple minutes for questions if we have time. Yeah, I appreciate your attention to this. I had a lot to cover.
Thanks so much, Pam. That was really great. And we do have time for some questions. If anyone has anything they want to ask Pam, you can unmute yourself or you can put a question in the chat if that's easier for you.
I did. Pam, hey, this is Brian Flick down in Brunswick with Marine Extension Sea Grant. That was awesome. Just I want to clarify. Did you say it's estimated $1 million per mile when it comes to evacuations?
That's what I've heard. It obviously depends on the amount of population. If you have a city, it's going to cost more. If you're in a fairly remote area where there's not a lot of people, then you don't have as much to do, but that was the estimate that I've heard.
Wow.
And that was a while back, even from Floyd. You might remember Floyd, 1979, I think.
Wow.
The forecast kept changing like a windshield wiper. So they would evacuate an area, then they'd say, oh, the Floyd's going to go somewhere else. So they have to evacuate somewhere else. So that was very expensive. And the clog on the interstates was just incredible because people were taking the interstates to try to get out of the area, out of the evacuation zone. And then they ran against other people that were trying to evacuate based on the newer forecasts. And so they really have to be careful. Some places take several days to evacuate, so they have to get these people out way ahead of time. And that costs money because you have to put out the warnings, you have to send um, emergency management people out to try to get people out of the areas that are the most in danger. So yeah, I think that's really it's amazing to me, and I'm sure some areas like Tampa or something is probably much higher cost than that.
Well, thank you, Pam. That's a fantastic presentation.
Yeah, and I have Megan has a copy of the slides, but if you send me an email, you see my address there. I'm happy to send you the email, and there's going to be a recording, I think, too. Um, and so hopefully one way or another you can get a copy of the slides. But if you want to use some of them, that I can either send you a PDF, which is smaller, or I can send you a PowerPoint so you can actually use the slides. And if you're going to send me an email, specify which you'd like to get.
Yeah, and this was recorded, and I can send that out to the invite list and the slides or PDF, however, whatever's easiest. Does anyone else have any questions? Okay. Well, I'll just share a little bit of information. We've got another presentation coming up in June, and see if I can share my screen and show you. Um, we'll have Jackie Jackson and Courtney Reich will be in to talk about planning for resilience and how that is scalable from what Chatham County is doing to other communities along the coast. So please feel free to tune into that one. I have not sent out an invite yet, but that will be coming soon. That's on June 10th. Uh, Pam, thank you again so much for the great conversation and the talk. Um, I know everyone here really enjoyed it, and I enjoyed it as well.
Thank you.
And everyone have a great March. Hopefully, we'll have an uneventful hurricane season.